Another day on section 5.3. Yesterday we talked about inverse functions and things along of that nature. What's going to happen today is we're going to have a goal of trying to find f inverse prime of a number. In other words, we're trying to find the derivative of the inverse of f at x equals some number. That's what we're really trying to figure out, all of this crazy stuff. Now, if you know how to find the inverse, then you find the inverse, you take the derivative, and you plug your number in. What's going to get tricky is when you can't do it. So I want to start with problem number 2 down here. And if I started with problem number 2 and I said, you know what we're going to do? We're going to set this derivative. Let's see. So if I want to find my inverse, I'd swap my variables. But the problem is I don't know how to solve for y. This isn't going to work. So what happens when I have a function like this? They're asking us to find the inverse, take the derivative, and plug 2 into that inverse. Well, if I can't find it, then we're kind of out of luck. So what I want to do is I want to come back up here and I want to look. We talked about these two problems, this f of x and this g of x, in yesterday's notes. We just got done doing this. There it was. Find the inverse of that root of the quantity 2x minus 3. We found its inverse. There it is, 1/2 x squared plus 3. And if you look at what we've got here, I'm referring back to that problem that we just did in the previous lesson. So I'm going to start by finding f prime of x at the point 6,3. What I want to do is I want to illustrate a relationship between the derivative and the derivative of an inverse. Okay, and here's what we're going to do. So I'm going to start f prime of x. Well, if I plug 6 into f, 2 times 6 is 12, minus 3 is 9, square root of 9 is going to be 3. So the point 6,3 is on f of x, and I'm going to use f of x as red here. Okay, so I'm going to start. Let's find f prime of x. F prime of x, 1/2 quantity 2x minus 3, negative 1/2 multiplied by 2, or how about better yet, 1 over the square root of 2x minus 3. So there's my derivative. So if I asked a person to find f prime of 6, 1 over the square root of 2 times 6 is 12 minus 3 is 9, square root of 9, this is going to end up being 1/3. So there, I did it. Okay, I'm going to use g of x as the blue one. Now remember, we just showed a minute ago that this is the same as f inverse of x. This is g of x is the same as f inverse of x. And let's write that so it looks like it's supposed to for when we look back at these notes. So f inverse of x is the same thing as g of x. So I'm going to say, let's find f inverse prime of x. Well, if I go to do that, take the derivative of 1/2 x squared plus 3, let's see. So I think that's going to ultimately end up just being x. So what is f inverse prime of 3? I'm going to end up with 6. Now, this is actually a pretty simple derivative here of this blue function. What I want to also point out is that when I look at x equals 3 for this g of x function, if I take 3 and I plug it in, 3 squared is 9 plus 3 is 12 divided by 2 is going to give me 6. So we've got partner points here. We've got the point 3, 6, and we've got the point 6, 3. And remember what we said, that the domain of f of x was the same as the range of its inverse and vice versa. So we've got these partner points going on. And when we have these partner points going on, what we're going to have is we're going to have this same relationship that we're going to notice every time. If I find f inverse prime of one partner, it's going to be the reciprocal. Whoops, I'm sorry. All this time I've had a 6 sitting here. This shouldn't be a 6. This should be a 3. If I plug 3 into that x, I'm going to get a 3. So here's my relationship. F inverse prime of 6 is going to be the same as 1 over f prime of its partner. F inverse prime of 3 is exactly the same as 1 over f prime of 6. And that's going to hold true every time. Now, how does that help us? Well, this problem down here is the one that we wanted to start to do in the first place. And we had this issue with number 3 where we couldn't find its inverse. So what we're going to do is we're going to take advantage of this green relationship in order to solve a problem like number 3. We're supposed to find f inverse prime of 2. So let's think about what we have. Let's compare the information that we're given in problem number 3 to what we were given in number 1 and number 2. F inverse prime of 2. So this 2 functions a lot like this 3 did. That 3 was an x value for f inverse. So the point 2, I don't know what, is on the inverse function. Well, then what does that mean? Well, if the domain of one function is the range of its inverse, then that would mean I don't know what 2 is on the f function. So here's how we're going to get around what you see in red down here on the bottom of the screen. We can't find the inverse. Well, if we can't find the inverse, our workaround is going to be this 2 is an x value for the inverse, but that must mean that it's a y value for the original function. So if that's the case, if I could find the x value that goes with it, if I could find this question mark value, then that question mark value is just like this 6 was. So our 2 here, I'm going to put it in blue, our 2 here functions just like the 3 did. Our question mark functions just like the 6 did. So f inverse prime of, in this case, our blue 2 is going to be exactly the same as 1 over f prime of whatever that question mark value comes out to be. So we just have to come up with what that question mark is, and this is how you're going to do it. We're going to take that 2. If that 2 is a y value of the f function, then we're going to set that 2 equal to our original function, equal to that function that was given to us. So in this case, this x cubed plus 2x minus 1 is the same thing as, well, it's the same thing as f of x, so set that equal to 2. So now what you have is you have an equation. If you want to know x cubed plus 2x, subtract the 2 over, minus 3. Now it's an x cubed equation. We've solved a lot of equations with our calculators, and in the interest of saving some time right here, I'm going to let you put that in your calculator and check it for yourself. What you're going to find out is you're going to end up with a wonderful little solution right here. You're going to end up finding out that x equals 1 is a solution to that equation, a nice simple solution. So what does this 1 mean? This 1 means our question mark is the number 1. So if f inverse prime of our blue 2 is the same as 1 over f prime of our question mark, that means what we really have is f inverse prime of 2 is the same as 1 over f prime of my 1. Well, do we have the capability of finding f prime of 1? Sure we do. What's f prime going to be? Well, let's do that work over here. F prime of x is going to be 3x squared plus 2. F prime of 1 is going to end up being, oh, what are we going to have? F prime of 1, 3 times 1 is 3 plus 2 is 5. It looks like my f inverse prime that I was asked to find is going to end up being 1/5. So to recap all of this, here's what we find out. When we're given a problem like this, when we're asked to find f inverse prime of a number, like we were in this target goal, f inverse prime of a number, the derivative of the inverse function of f at whatever number we're given, this number that we are given, this 2, is going to be a y. This 2 is an x value for the inverse, but it's really a y value for your original function. So set that 2 equal to your original function. Solve for the x value that goes with it. F inverse prime of 2 is the same as 1 over f prime of its partner. And I'd much rather find the derivative of that f function than find it of the inverse function. So this is an AP topic. You are going to have to see this, and it is pretty abstract. So if this was a little confusing, that's okay. You are not alone. We'll do more to try to get better at it.